Hey guys, it's Miss Adams, and we're on the second page of the Unit 11 test review, and we're going to start looking at a few of these applications. So this first one says that Henry throws a tennis ball over his house. The ball is 10 feet above the ground when he let it go. The quadratic function that models the height in feet of the ball after x seconds is f of x equals negative 3x squared plus 2x plus 10. This is asking how long does it take for the ball to hit the ground. So guys, we got to find some keywords there. We're looking for how long. So that's a time. And this has to hit the ground. So I know that I'm going to have a height equal to 0. Guys, in this case, our height represents our y value. So the only time that y equals 0 is when we have an x-intercept. So anytime you see that we're looking for a time with a height of 0, we're looking for our x-intercepts, okay? Guys, you can do this by any method that you choose. You can factor. You can plug it into the calculator to find your x-intercepts. But guys, we want to see you show some work. Easiest way to do that, in my opinion, is just go ahead and put it into the quadratic formula. So I've got x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a, where our b value in this case is 2. Our a value in this case is negative 3. And c is equal to 10. So in our calculator, I'm just going to put those values in. So give me just a moment. And guys, make sure that we're putting those parentheses in our calculator. Make sure we're watching for our negative signs versus subtraction. And when we put these in the calculator, you should get 2 different solutions. It's going to look a little different. So it should look something along the lines of x equals. You may get something that looks like this. So like, 1 plus the square root of 31 over 3. And x equals 1 minus the square root of 31 over 3. But when I convert those to decimal values, I should get the 2 decimal values of approximately, approximately negative 1.5 and approximately 2.2. But guys, remember, we're dealing with time here. So that x value represents time in seconds. Guys, our time can't be negative. So therefore, the only true solution in this case is the 2.2 seconds. Let's go to problem number 9. So it says, Mr. Sakita, a basketball expert, launches the basketball into the air while playing a basketball game. The path of the ball can be modeled by the following equation. B times t is equal to negative 4t squared plus 8t plus 6. So guys, this is asking what is the maximum height of the ball. So now we've got this word maximum. As soon as you see maximum, you need to think of vertex. Remember, your vertex is going to be an ordered pair, x, comma, y. Your x value represents time. Your y value is going to represent your height. So we have this equation that says x equals negative b over 2a. But notice that in the formula, we're actually using the variable t instead of the variable x. So I'm going to set this up as t is equal to negative b over 2a, where my b value, sorry about that, guys, where my b value is 8, and my a value is negative 4. So that's going to give me negative 8 divided by negative 8. So I know that my time in this case is 1 second. But I didn't ask for the time that passed. I asked for what the maximum height will be. So I'm going to take that time of 1 and plug it back into the original equation. So I'm going to find the height of the ball after 1 second. And I know that's going to be equal to negative 4 times 1 squared plus 8 times 1 plus 6. Remember, my time being 1. Negative 4 times 1 squared. Well, 1 squared is just 1. 1 times negative 4 is negative 4. And guys, remember, you could just plug this directly into your calculator as well. So I got negative 4 plus 8 gives me a positive 4. then 4 plus 6 is going to yield a height of 10 feet. So the maximum height that this ball is going to reach is 10 feet. All right, let's go on page 3. And we're going to take a pause from that just for a second. So a pause from our word problems here. And it says set up the quadratic formula. So guys, we're not asking you to solve it. We just want you to set this up. Which means the only thing we're asking you to do is identify your A value, which is 3. Identify your B value, which is -5. Identify your C value, which is 2. And now plug it into the formula. So x equals -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a, where your b value is -5, your a value is 3, and your c value is 2. So we just wanted you to set it up. That's going to lead us to problem 11. So Chase is selling fidget spinners, and his projected return can be modeled by the following function. F of x equals -3x squared plus 48x plus 4, where x is going to represent the amount of fidget spinners sold. So guys, it says find the peak profitability, or the vertex of the function, and fill in the blanks to complete the sentence below. So we've got to figure out where is going to be the maximum profit. So that's what it means by peak profitability. So we're going to use that equation that we had above. I know that x equals -b over 2a. And in this case, I'm going to say -48 divided by 2 times -3. So I've got my -48 divided by 2 times -3. That gives me -48 divided by -6. So I know I'm going to have an x value at 8. So then I'm going to take that value of 8 and plug it back in to figure out how many fidget spinners are going to be sold. So I'm going to find my function at the value of 8 is equal to -3 times 8 squared plus 48 times 8 plus 4. So I'm just plugging the value of 8 in there. And guys, I recommend just plugging this into a calculator. So I've got, let's see here. So I've got -3 Give me just a second, guys, because my calculator decided to not work on me, so I'm having to actually use the calculator on the computer, but that's okay. It works just as good. So guys, when you're plugging this in, just make sure that you value the negative signs. So I had -3 times 8 squared plus 48 times 8 plus 4. Guys, this is going to give me 196 fidget spinners. So the vertex in this case of 8, 196 means that after selling 8 fidget spinners, Chase will make a maximum profit of $196. So he made 8 fidget spinners, and he's going to make a total max profit of $196. So now we're dealing with Chase's fidget spinners again. So Chase is selling these fidget spinners, and projected return can be modeled by the following function. And it says, what is the initial amount of fidget spinners Chase would need to sell to not lose money? Guys, we didn't word this very well. So really, in order to do that, we're going to need a break-even point in order to do that. So we're not going to worry about that too much right now. what I would really want you to focus on is we're going to see the initial amount of money that he would need to put in. So the initial amount that he would start with. Guys, anytime we say initial amount, like that's all we're trying to get you to get to view at this point. So anytime you see those words initial, I want you to think of the y-intercept. So guys, I know that this problem doesn't make all that much sense, but I want you to know that the initial amount here in this case was 4 because that is your y-intercept. So guys, let's not focus too much on the wording of that problem. That was our fault. We will change the wordings for future years, but for right now, we're going to go with the initial amount in this case was 4. Okay, so now let's move on to problem 13. In problem 13, we're trying to launch a ball to hit a target that is 30 feet away. We've calculated that in order to hit the target, you're going to need to launch a ball with the following quadratic function. It says h of t equals negative 3t squared plus 7t plus 6, where t represents time in seconds. It says how many seconds will it take for the ball to hit its target? Guys, remember, we're trying to find a time here. We're trying to hit the target, so that's when our height is 0. So if you see, when we're trying to figure out how many seconds it's going to take to hit a target, we're trying to find our x-intercepts. And I'm just going to go the easy route and use the quadratic formula. So negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a, where my b value is 7, my a value is negative 3, and my c value is 6. So I'm going to plug this into my calculator. And that gives me 2 different x-intercepts here. It tells me I got x equals negative 2/3 and x equals 3. But guys, can time ever be negative? That is a no. We can't travel back in time. So the true answer here is that it's going to take 3 seconds to hit the target. And guys, we're also talking about launching a ball. We've got gravity here. So if I'm figuring out which way this parabola opens, notice that my a value is negative. If your a value is negative, you're going to open downwards. It is negative facing. So our opening is down. Remember, that's a sad face. And guys, we're going to look at number 14. It says a cannonball is shot from the side of the hill. So this is the same idea here. The motion of the cannonball can be described by the equation h of t equals negative 3t squared plus 25t plus 50, where t is the time in seconds and the height is represented in feet. If the two solutions are negative 1.67 repeating, or negative 1.6 repeating, and 10, how many true solutions or x-intercepts exist for this problem? So guys, this is going back up to kind of like we did before. Notice we had a positive and a negative solution, but we're dealing with time here. So there's only one true solution because time cannot be negative. Guys, in our last video, so we're going to pause here. Last video, we're going to focus on the square root method.